Hi everyone, I'm Ramnandan Krishnamurthy from the Azure Cosmos DB team, and I'm joined by my colleague Ewan Garden from the Azure Synapse Analytics team. And together, we're very excited to welcome you to this session where we will cover the features of Azure Synapse Link for Cosmos DB and how it helps you build real-time analytics and BI solutions with great performance, cost effectiveness, and low operational complexity at scale. We've planned a very interesting session today, and here is at a very high level the agenda for the session. We'll start by providing an overview of Synapse Link for Cosmos DB for those of you who are new, and then we'll jump into the latest updates since we announced public preview at Build earlier this year. We've prepared some cool demos to walk you through end-to-end analytics and BI scenarios that you can achieve with the rich ecosystem of offerings we have in Azure Synapse Analytics. And finally, we'll also walk you through some sample industry vertical use cases. So let's dive right in. As you all know, Cosmos DB is Azure's fully managed NoSQL database offering for modern application development. Over the years, customers have chosen Cosmos DB as the cloud-native operational database to back their mission-critical platforms in their digital transformation journey. While app development, though, is only one half of the story, we've seen from working with a lot of our customers that they almost always want to generate rich insights out of the data that their applications store. For instance, wanting to implement fraud detection over live order transaction data in retail, or anomaly detection over IoT sensor data in the oil and gas sector. Pretty much across the industry verticals, customers are adopting a data-driven culture. And at the core of this culture is the need to deliver analytics over real-time operational data at scale to transform existing business processes and stay ahead of the curve. Before Synapse Link, there existed primarily two options to achieve real-time analytics over Azure Cosmos DB data. First, by running analytical workloads directly on Cosmos DB along with the transactional workloads. While you could try to isolate the analytical workloads by running them on secondary replicas, the performance of typical analytical queries degrades as the volume of operational data increases and can be very resource intensive. So the other option to ensure there is no performance impact to OLTP workloads has been one where data engineers create and operationalize pipelines to periodically move data from Cosmos DB to a data lake. These pipelines must be then monitored and managed throughout their lifetime. Further, once the data lands in the data lake, data engineers have to continuously ensure that the data is in an optimized columnar format for their analytical workload needs as the data evolves upstream. It is only after this that the data can then be transformed, enriched, and served in analytical workloads. Thus, the analytical workloads are not running against the latest state of operational data, leading to delayed insights. And this is where the power of Azure Synapse Link for Cosmos DB comes in. Synapse Link is the first cloud-native hybrid transactional and analytical processing or HTAP capability that enables you to run analytics over your operational data with no ETL and no performance impact on your transactional workloads. Azure Synapse Link for Cosmos DB finally breaks down the barrier that has long existed between OLTP and OLAP systems. So, what's the magic powering Synapse Link? So far, prior to Synapse Link, your operational data in Cosmos DB is internally stored in a row-oriented transactional store. This store is optimized for transactional reads and writes and operational queries. Now, with Synapse Link, we've added a fully managed native analytical store within a Cosmos DB container. The analytical store is a fully isolated columnar store optimized for typical analytical queries over large volumes of data. Any new inserts, updates, deletes to operational data are automatically synced from the transactional store into the analytical store in near real time within a couple of minutes. This auto sync capability does not consume RUs which you have provisioned for your transactional workloads. Finally, with Synapse Link, you can connect the Cosmos DB analytical store with Synapse Analytics workspaces with a single click, which then allows you to interchangeably query operational data in Cosmos DB using Spark and SQL runtimes in Synapse with no RU impact. This now enables you to build machine learning pipelines, BI dashboards, and run big data analytics in near real time on your operational data. And now, coming to the latest updates. First, we're excited to announce public preview of Synapse SQL Serverless support for querying Azure Cosmos DB starting October 2020. This now allows users to run analytical queries using their familiar T-SQL syntax over Cosmos DB analytical store in place within seconds without needing to copy or load the data into a specialized store. It also enables BI engineers to build near real-time dashboards using the native Power BI integration in Azure Synapse over Cosmos DB data, as we'll see in just a short bit in the demo. It's not just Power BI, but you can connect to a wide range of BI reporting and ad hoc querying tools using the well-supported T-SQL interface. Another very cool capability that is now unlocked is the ability to build a logical data warehouse where you can create and analyze a unified view of data across Cosmos DB, Azure Data Lake Storage, and Azure Blob Storage without having to move data into managed tables. We've seen great response during the gated preview and are looking forward to seeing and learning more about how you adopt this cool HTAP feature in your architectures. Next, we're also very excited to announce public preview of support for Azure Cosmos DB API for MongoDB in Synapse Link, along with the core SQL API of Cosmos DB, which is already in public preview for Synapse Link. Synapse Link now provides a cloud-native HTAP capability for customers who have chosen to build their application stack on MongoDB in the cloud by choosing the Cosmos DB API for MongoDB. The general principle of Synapse Link applies as is for the MongoDB API as well. Users can run Spark as well as T-SQL queries against the data in Mongo collections with no impact to OLTP workloads and no explicit ETL needed. Further, we have made an additional investment in how we manage the schema of the analytical store during the fully managed auto-sync functionality, especially for highly polymorphic NoSQL schemas, which we love in Cosmos DB being a schema-agnostic NoSQL system. To provide an optimized storage representation for analytical workloads, Cosmos DB creates a tabular schematized representation of the data in analytical store, even when the data in the transactional store is non-schematized. This poses two unique constraints. What if the same property contains values of differing data types across items in the transactional store? For instance, in this example, the purchase date property contains values of both string and integer data types. Similarly, what if properties of array type contain values of differing data types? For instance, product vector property in this example contains values of integer, double, and mixed string data type. Typically, this adds a lot of overhead in ETL scripts to account for such schema variants when users have to manage OLTP and OLAP systems separately themselves. Luckily, with the fully managed auto-sync functionality of Synapse Link, this disambiguation is automatically performed as shown here in the analytical store. The schema variance is clearly disambiguated by extending property names by data types in the analytical store, such that users can query the appropriate columns based on their needs at runtime without any loss of data. This full fidelity schema representation is the default experience when Synapse Link is enabled for MongoDB API accounts now, and you can learn more about the full fidelity schema representation by reading our documentation. Before we jump into a demo, I would like to walk you through some end-to-end analytics and BI patterns that can now be realized with Azure Synapse Link for Cosmos DB. Using the SQL Serverless runtime in Synapse Link, you can create SQL views over Cosmos DB Analytical Store and connect these views to Power BI to build rich direct query BI dashboards. And you can also perform ad hoc data exploration by executing T-SQL queries from both the Synapse Studio as well as any remote SQL client. Using the Spark runtime in Synapse Link, you can transform and enrich data from the Cosmos DB Analytical Store and perform big data analytics using Scala, Python, Spark SQL, and C#. You can also leverage Spark ML as well as Synapse's deep integration with Azure Machine Learning to build and train ML models, reading data from the Cosmos DB Analytical Store via Spark. If you have a data warehouse serving users today, and you wish to incorporate the operational data from Cosmos DB, you can curate and export Synapse Link data with just a few simple steps in Spark 2. I think I can hear the obvious question you have in mind. What if I have data in other operational databases and external systems that I wish to analyze in conjunction with Synapse Link data? Synapse Analytics' rich data orchestration capabilities allows you to bring data from these external data systems into an Azure Data Lake Gen 2 store, and then allows you to leverage Spark, Synapse Spark, and SQL to achieve the mentioned analytics, BI, and ML scenarios over your holistic data estate in conjunction with Cosmos DB data. With that, let's go into the demo. In this demo scenario, we're going to take an electronics retail chain looking to build their new age supply chain management platform on Azure with their operational platform on Azure Cosmos DB API for MongoDB and their analytics platform on Azure Synapse Analytics. We're going to explore how Synapse Link for Cosmos DB enables users to build rich BI dashboards over the live inventory data in Cosmos DB, as well as query this data in an ad hoc manner to answer key business questions without any impact to the transactional workloads. And for this, let me switch over to the Azure Synapse Analytics workspace, where I'm going to show you this BI dashboard. So this BI dashboard you see right here is built over the live Cosmos DB data using SQL Serverless in Synapse Link. One thing I'd like to point out is this dashboard is built using direct query in Power BI, and hence, as I make updates or changes to the filters here, for instance, if I choose a particular product SKU or make any other updates, the data automatically, the dashboard reflects to based on the underlying data. And let me quickly show you how easy it is to build such a BI dashboard over Cosmos DB now. For that, let me show you the SQL script. Here you can see that I'm creating a T-SQL view over my Cosmos DB data and creating this view in the SQL database called SQL Serverless DB. And let me show you that database right here. So if I switch over to the data tab, I can see this database here, and I can see this view which I've pre-created here, which is the surface retail sales. And just FYI, you can also see the Cosmos DB database and collections, which are now in Synapse Analytics workspace once I enable Synapse Link. So let me actually show you something a little more interesting as well for ad hoc query exploration. So here in this BI dashboard, something pops out, which is that in store ID 111, the demand for inventory for the Surface Go product is significantly higher. So now I want to run an interesting experiment, which is my data scientists have created a forecasting model which has predicted the demand inventory for different stores for the following week. I want to take this, join that data, and that data is currently stored in an ADLS container. And I want to join that data from ADLS as well as this live operational data I have in Cosmos DB. Let's see how easy it is to do such ad hoc data exploration using SQL Serverless in Synapse Link. For that, let me show you this other SQL script here. And here, before we come to that particular query, I want to introduce you to the syntax which makes it super easy to query Cosmos DB data using T-SQL. Here you can see an open row set capability, which allows you to very seamlessly query Cosmos DB data by just providing the Cosmos DB account details along with the Cosmos DB container name. And SQL Serverless provides an out-of-the-box schema inference capability, which allows you to explore data when you're not really sure of what you're looking for. But once you've explored your data and you know particularly which columns you want to query, in order to improve the efficiency of the queries, you can then specify the schema in the T-SQL query. And one thing I'd like to point out here is, if you remember the full fidelity schema representation in Mongo API, which I spoke about, that's exactly what is being leveraged here. So here, a Cosmos DB Analytical Store has already disambiguated different data types for a particular property in my operational store, and I can then choose the right data type I want to query on, and then seamlessly query using SQL Serverless. Also, you can very seamlessly, as previously showed, create a SQL view over individual Cosmos DB containers, as well as a view over a join across the 3 containers, which is what we had done for the Power BI dashboard. And finally, for the query which we were interested in here, right? So in interest of time, I've already created a SQL view called retail sales over the forecast data, which is there in an ADLS account. And I want to then join this data with the data in the product collection in Cosmos DB, for which I've here created a SQL view over the product container in Cosmos DB. Then it allows me to write very expressive T-SQL queries to answer the business questions I'm interested in. And here, let me show you how easy it is to now run such queries in an ad hoc manner over Cosmos DB. So here I'm leveraging this SQL Serverless capability in Synapse Analytics. And within a few seconds, I can now see the data, which has the results of these queries, which is joining data across Cosmos DB and ADLS to answer the questions I'm interested in. With that, let me pass it back to Ewan. Ewan, take it over.
Thanks, Ram. I think it's great to be able to see the continued innovation that the two teams have been able to undertake since we've initially launched Synapse Link earlier on this year. And those demos are really cool, and I think that our audience will absolutely love them. Now, as Ram has been showing you a bunch of features of Azure Synapse Analytics already and talking about it a little bit with slides, I thought I would try and give a little whirlwind tour of some of the other capabilities for those of you who are not as familiar as others may be. So we can see here, I'm actually inside of the Synapse Analytics Studio, which is the primary user interface that we have. And I'm going to go ahead here and show you that what we've got going on is we've got ourselves a notebook which is attached to this analytics pool, which is a Spark pool. And we've also got Python selected as our language here. So we could have chosen C#, Scala, Spark SQL. Not everything you're going to see here is possible in Spark SQL, but Python is the most popular language for Spark these days. It's been on a fairly dramatic growth curve, and so that's what we're going to go ahead and use. So let's walk through this notebook and see what's going on. So first of all, we're actually going to repeat some of the work that Ram already did, except he did it with SQL on demand. We're going to go ahead and do it with Spark. And so here you can see us, we're going to load in the products table. I'm going to create a data frame out of it. And we're going to do that by reading directly out of the Cosmos store. So we're not ETLing the data, we're not landing it in the lake, we're not using any fancy tools, we're just simply doing a read directly against the Cosmos store. So this is super efficient and very easy to go ahead and do. So that's the products table. Then we're going to go ahead and load the sales table. Again, these turn into data frames. And so those first 2 data frames were populated directly from the Cosmos DB store. Now this third data frame is a little different. In this particular case, we're actually going to read it out of the lake, and it's going to use the Delta Lake format. We support Linux Foundation version of Delta Lake. And so that's the one we're going to go use here. And you can see it's a fairly standard read operation in Spark. So now we have 3 data frames. So of course, what do you do when you have 3 data frames? You join them together to create a new single data frame. So we're going to go ahead and do that. Now you can see here that we're doing a little bit of a trick. We're going to use broadcast joins, because having played with this data a little bit, I know that 2 of the data frames are very small, and the third data frame is actually fairly large. And so this is a nice efficient way to be able to do that join. You'll also see in this cell, there's a couple of little debug statements I've got commented out. So the first is a time it. Time it is a cell level magic. It's going to give me very precise timing on how long the cell took to run, and when I was trying to make sure that the join was better and faster, that's what I was using. And it gives me more precision than I get down here. And then we have a display, and we're actually going to cover the display a little bit later, so ignore that for just now. But you'll notice that all the cells have a display on them, and that's to help debugging. All right, so now we have our join data set. We're going to go ahead and clean it because the data is never clean. It's never exactly what we need it to be. And so first thing we're going to do is drop some unnecessary columns that we pulled through as part of the join. And then we're going to fix up some column types. There's a whole bunch of string columns that should really be floats, and one which is a string that should really be a date. So we'll go ahead and do those type conversions inside the data frame. And then to replicate the work that Ram did, we're going to go ahead and we're going to create a derived column, which is sales, which is price times quantity. And we're also going to filter out a bunch of the data based on the high income ratio being higher than 0.9. And that represents effectively the same processing that you saw earlier on. So we're done, we think, with our data at this point in time. We've converted the types, we've done some filtering. So now we need to explore the data set and see if it matches what we expect and if it's going to be useful to us. So the first thing we're going to do here is simply print the schema. And we can see that if we look over here, we can see that quantity is now a float. We can see that week starting is now a date. So we definitely managed to improve the situation from everything being strings. But we really want to look at the data as much as we want to look at the schema. And that's what this display command that you see here is all about. Now I could have done head and I could have done show and some of those other commands which are popular in Python and also in Spark. But the way the output comes out is not the easiest to read, particularly if you have lots of columns, doing the console ASCII art thing. And so by using this display function, which is something that we've added, you can now get a nice clean table. And so here we can see a nice scrollable table. It's nice and fast. And you can see all different columns that we've got here, and it scrolls way over to the right. I can bring up this properties here, and I can filter the data based on a particular column. And I also can look at the data in a graphical form using a chart. So if I flip over here, we'll see that we've actually got a default chart which doesn't make a lot of sense. So let's very quickly go ahead and beef that up. So we'll go ahead and we'll check the line chart here. For our series group, we want product code. For our values, we actually want sales in this particular case. And then for our key, we actually want the week beginning or the week starting column. All right, so we've done all that. Let's go ahead and apply those changes. Now we could have done this where we'd actually push the sum through into the back end. Because if this is a billion rows, obviously you don't want to pull it all through and try and display it in an HTML chart. And so in this particular case, the data is not that big, and so we're actually computing the sum on the data frame. But by selecting that aggregation overall results option, it'll actually generate a slightly different query, and it'll go ahead and generate the aggregates on the back end for you. So we can easily see here that, in fact, we have a nice little graph. We can get rid of this UI if we want to, just hide this out of the way to give us a little more real estate here. And you can see that the Surface Laptop 3 is the most popular seller in general. That seems sensible. It's a really cool device. We can also see the dates formatting and sorting correctly, so that's really helpful. That means that format conversion worked great. I can also, in here, if I want to, I can open up our monitoring UI, or if you're used to using the built-in open source tools for Spark, then we can go over here and we can take a look at what's actually going on. If you've never seen these tools, they can be a little intense, but here we can see what's going on with the different executor views, the different stages which are happening inside of the UI. We can take a look at all the different jobs in here, and we can see the behavior of those executors when they came online and what work they did. Go ahead and close that up. All right, let's keep taking a look at this. So that was great that we have charting, but there's another capability that we added here to the display function. Ooh, I thought I could spell true correctly. And here we're going to ask for a summary of the data. And so instead of seeing the data, we're actually going to get a summary. So let's pick on the sales column here. And so it's going to run a query, and it's going to take a look at statistics for it. And so if you see here, we end up with a histogram of the sales column. We end up with basic stats, min, max, mean, standard deviation. So now I think I've developed a really good understanding of what's going on with my data, and I really like it. what am I going to do with it next? Well, the next thing I'm going to do with it is I'm going to create a table in the catalog using the data so that it can be used tomorrow, the day after, because data frames only exist within a session. So I'm going to save this data away and others can use it, or I can come back and use it. So if I've saved it away in the catalog, let's see what I can actually do with it. So if we go ahead and switch to our storage node, you'll see here it's already appeared. If it doesn't appear for you, then just hit the refresh. But you can see it's already appeared. And I'm going to choose some actions. Now I can go ahead and create a new notebook and load it in. That's handy. But a new SQL script and select top 100 rows. I wonder what that does. And let's see. Okay. So if we take a look up at the top here, and we're not using a notebook this time, we're using a SQL script, but you can see we're actually using SQL on demand. So what happened here was we saved a table, we saved it into the Spark catalog. It was then synced into the SQL catalog, and so it appears in SQL. And so now we know how to query it in SQL. So let's go ahead and do that. So if we just switch out of zoom in mode. So now we've run a SQL on demand query, just like Ron was doing. And you can see in the grid, here's all of my data. I can flip around and I can see a chart. So a very similar experience, except now I'm using a SQL endpoint instead of using a Spark endpoint to go ahead and connect to this. Let's go back to our Spark experience. And if you take a look at this query here, you'll see it looks remarkably familiar to some of the queries that Ram was running, except we're back in Spark land. So if I want to, I can go ahead and run a Spark SQL query against the same table. Here we see surface sales feature DF, and do anything that Spark SQL can go ahead and do. And here we can see the execution plan. All right, let's switch to another notebook to show some other functionality here. So one of the things we get a lot of feedback from customers on is, hey, I want to be able to manipulate the file system. I want to be able to look through files because we have very complex storage patterns inside of our data. So that's what we have here. So we've created a new library, MS utils. The name will change slightly by the time you watch this video to MS Spark utils. That allows me to do a whole bunch of standard file system commands: copy, move, list, make directories, and delete. If we go ahead and take a look at this here, we can see that it's going to go ahead and give a list of files. If we enumerate the list of files here into a variable, and we can loop over all those files and we look at properties of them. So here we can see we have 2 directories. One's full of images. There's 3 images. Those are actually the 3 different products that you saw earlier on. We can see the Delta log subdirectory, which is because we're using the Delta format. Now this notebook has a couple of interesting things in it. If we take a look at the top here, we'll see it has parameters. And so this is a parameterized notebook, and so we can go ahead and override this value anytime we want to when we operationalize. So let me go ahead and say, let's take this notebook and add it to a new pipeline. If you're familiar with ADF, this will be nothing new to you. So here we've got a notebook we're going to execute. I'm going to go into settings here, and I'm going to set base parameters. And I can go ahead and I can turn around and set and override that parameterized value. So when the notebook is overridden, I can enumerate a different directory, I can have different settings. And so parameterized notebooks really help when you're trying to operationalize and make things a little more production ready and more robust. All right, let's go ahead and go back to the slides. Here we go. So we saw the demo. Now, one of the things is Ron and I have talked about a lot of technology over the course of the last 25 plus minutes. But how do you go ahead and use it, and how do you go ahead and deploy it? So we have a series of patterns. And this is a very common one here, which is supply chain analytics with forecasting and reporting built on top of it. And here you can see a bunch of different technologies, Azure Data Factory, but Cosmos DB is at the core, both the transactional store and the analytical store. And that data frame that we created, which had to join of the 3 existing data frames in it, could have been used to do BI on top of by using SQL Serverless. You can see that here under operational reporting. You can also see us using Spark to do some data processing, and we can use Azure ML to do machine learning on top of that same data set. And so very familiar patterns, but much simplified because of the ability to use Cosmos DB's transactional and analytical store, and to use Azure Synapse and the different analytical engines that we have there. Real-time personalization, very common scenario. Lots of people want to do that today. And so again, we've got Azure Synapse at the core. We use Spark as a processing pipeline for the ML, and we're able to deploy that processing engine out to Azure Kubernetes services and be able to do recommendations in real time for shoppers on a website. IoT, again, another very popular scenario right now. And one of the important things about this architecture is, well, we have mostly focused this conversation today on what we call HTAP, which is the hybrid analytics and transactional store. And you can see that over on the right-hand side, all up and running in Azure, along with Azure Machine Learning, Power BI, a whole bunch of different technologies. We can't forget about the edge. The IoT devices need to talk to the edge. And we want to be able to run machine learning models on the edge closer to the data, and also because there may be problems with routable protocols and stuff like that. And so in this particular case, we've extended the architecture to include the edge, but the core is similar to what you'd seen in the previous slides. All right, so let's summarize what we've seen in this session today. We've seen how to unlock near real-time no-ETL analytics. We're using Synapse Link. We showed this earlier on this year, but we've added a new twist to that, which is support for SQL Serverless. Now, the SQL Serverless capability is going to be available at the beginning of October. It's not quite ready yet. Once we've deployed it worldwide, then you'll all be able to play with it and see how it works. We also saw at the beginning with the work that Ram was demoing, the Cosmos DB API for Mongo. So now you have Mongo available to you, as well as SQL Serverless. So we're expanding on both sides of Synapse Link. In terms of Spark, what you can play with now, if you have access to Azure Synapse Analytics, those enhanced notebooks that you saw in terms of the UI, the display function, we add new magics, so things like some of the time it functions and things like that are all there. The MS Spark utils library will be deployed by the time you're able to watch this. We'll have changed the names, as I said. And then a big new capability that's coming on the Spark side is actually coming in the October timeframe, and it's running in what you saw today, but it's hard to demo. And that's a new caching and shuffle service. If you take a look at performance of Spark, you'll see that anytime you have to go to the file system instead of using memory, then it gets very expensive. And shuffling becomes very expensive, and therefore caching storage also becomes very expensive. So we've written from the ground up a native shuffling and caching service. But one of the nice things about the caching service is it's very aware of what it's running on. So for example, Azure Data Lake Storage Gen 2 has a query acceleration capability which supports predicate pushdown. This caching service is aware of that. If it's running on the right storage, it can use it. If it's not, then it'll continue to do the predicate pushdowns itself. It's also aware of hardware. We've talked and demoed very briefly in the past our use of FPGAs to do file parsing, particularly for CSV files. The caching service is also aware of that. So it knows when to push down to the FPGAs. So it's a very exciting evolution, and the caching and shuffle service forms the basis of a lot of our performance improvements going forwards. All right, so to conclude, Ram and I covered a lot of ground in half an hour. I'm sure you have lots of questions. Our email addresses are there, our Twitter handles are there. There's also a dedicated alias that we have for asking questions about Synapse Link. If you want to see the announcements which come out, you can go take a look at the Twitter tags that we have there. And we have samples already, fairly broad set of samples and notebooks available on both the Synapse side and also on the Synapse Link side. So I'd like to actually go ahead and thank you for your time today. It was my pleasure to be able to talk to you. I hope you found the content useful and exciting, and we'll look forward to talking to you again. Thank you.